Back. So in the previous lesson, our goal here was to understand what rational exponents mean. That is, what something like 2 to the 1/2 or 2 to the 1/3 really mean. We used the graph of 2 to the x to help us kind of estimate this. We zoomed in on the 2 to the x like this and tried to estimate, for 1/2 and for about 1/3, what these values were, to help us get at least a decimal approximation here. Okay, but now we'll look a little more closely at some things. So if you scroll down here, we're actually going to let the cat out of the bag and just go to the lesson summary at the end here. Okay. So we talk about roots, right? And we talk about square roots. We also have cube roots and other roots like fourth roots and fifth roots and so on and so forth kind of thing. Okay, and in general, if b is equal to a to the n, then we say that a is the nth root of b. Okay, so in other words, if this is true, that means that this is also true. These are equivalent statements. Okay? So, how does that factor into what we're talking about now? Okay, if we have b to the 1 over n power, that is the same thing as the nth root of b. So these two things are equivalent. Okay, so if you have 4 to the 1/2 power, that gives you the same thing as the square root of 4, our base there. Okay. Likewise here, if you have b to a m over n, the m becomes the exponent of b, and the n becomes the root of the b. And you can write it either this order or this order. Here the m is inside with the b, and the nth root is on the outside. Here the nth root is on the inside, and the power of m is on the outside. Either one is acceptable, and they're both equivalent to each other. Of course, if you throw a negative in front, same kind of principle applies as in earlier times when the negative moves it to the denominator, and positive exponents then. Okay, so let's take a look at that in practice up here, and I think it'll maybe make some more sense when we see some problems. Okay, I'm going to skip these. I mean, it is helpful to see, okay, the 4th root of 16, so that would be the 4th root of 16 is 2, right? Because 2 to the 4th equals 16, so therefore this is true. Okay, the cube root of 125. So in other words, what number when you multiply by itself 3 times gives you 125? The answer is 5. What is the 5th root of 100,000? Well, that's going to be 10. Okay, because 100,000 is 10 to the 5th. All right. Let's evaluate these expressions now. So 4th root of 81. Well, in this case, we can rewrite that 4th root of 81 as the 4th root of 3 to the 4th. Okay, if you want to take this a step further, we could take that 4th root and rewrite it as 3 to the 4th to the 1/4 power, using our rational exponents there. In which case you would multiply those two exponents together, right? And 4 times 1/4 is 1. So this is just 3. Okay, the 5th root of 32 is 2. Okay, the cube root of 9 times the cube root of 3. Well, we can't really easily take the cube root of 9, right? There is no 9 is not a perfect cube, nor is 3 a perfect cube. But what we can do is use our properties here and say, okay, this is the same as the cube root of 9 times 3, which is the cube root of 27. And 27 is a perfect cube. Okay, so 27 is 3 cubed, which means we would just get 3 here as well. Okay, for this situation, we have the 4th root. So again, we're not quite ready to take the 4th root of 25 because that's not a nice number. It doesn't work out evenly. Same thing with 100, same thing with 4. So what we'll do is we'll multiply these all together. Oops, which gives us the 4th root of 10,000. 10,000 is 10 to the 4th. So the 4th root of 10 to the 4th is just going to give us 10. Again, if you don't like that, remember you can rewrite the fourth root as, as a fractional exponent and make this here be 10 to the fourth to the 1/4 power. That's what the fourth root will become there, the 1/4 power. And then you multiply your exponents there and you get 10 to the 1. Okay? So discussion here. If 2 to the 1/2 is equal to the square root of 2, and 2 to the 1/3 is equal to the cube root of 2, what does 2 to the 3/4 equal? Well, let's do this. We know that 2 to the 3/4 can be rewritten as 2 to the 3 to the 1/4, like that. Right? Multiply those powers together, you'll get right back to the 3/4 there. So this is equivalent. Alternatively, we could also write it as 2 to the 1/4 to the 3rd. Again, multiply these powers back together, you're going to be right back there at the 3/4. Why is this significant? Well, we know what the fourth root is. The fourth root is going to be just this. Or, to the 1/4 power, it gives us the fourth root here. And that 2 to the 3 will be on the inside. Okay? Here in this situation, since we're cubing on the outside, will be something cubed. 2 to the 1/4, that again is the fourth root of 2. So, either of these are acceptable answers. So you see here that in general, that exponent of 3, the numerator becomes the exponent, and the denominator becomes the root. Okay, and we'll get into that in the exercises 2 through 8 in the next video.